Dear students, today we are going to discuss about finite and infinite sets. Finite and infinite sets. So as we discussed earlier, so in terms of the number of elements, the sets are classified, and in the last class we have discussed empty set or null set, or sometimes known as void set. So a set having no elements is called empty set or null set or void set. If the number of elements is finite, then we call it is finite set, and otherwise it is infinite set. So a set having finite number of elements is called finite set, and infinite number of elements is infinite set. In Spain, in the example 1, 2, 3, 4, 5. So there are 5 natural numbers are given here. So number of elements is finite. So it is finite set. Similarly, in the next set B, A, B, C, D, E, G, just a collection of few alphabets. So this is also a finite set because of having finite number of elements. And the number of elements of a set is written just n, small n of s, this number of elements in the set. Infinite sets, if we take some examples, then you have collection of natural numbers, which is infinite set. Collection of odd integers, even integers, whole numbers, real numbers, rational numbers, all these are infinite sets. So only in terms of the number we can say a set, whether a set is finite or infinite. Next, look at few examples here which are given in set builder form. You see example 6 sub 1, x belongs to n, x is natural, and x minus 1, x minus 2 is equal to 0. So from this definition we have, from the second conditions we have x minus 1 into x minus 2 equal to 0. This gives us two values of x, 1 and 2. And from the first condition, x is natural. Yes, 1 and 2 are natural. So this set consists of two elements, 1 and 2. It's finite set, only two elements, 1 and 2. In the second example, if you see x square equal to 4, x is natural number. So x square equal to 4, from this condition we can have the values of x 2 and minus 2. 2 and minus 2, that means two values of x we are getting here. But from the first condition x must be natural. So therefore 2 and minus 2, both the elements we cannot consider in this set, because n is natural, so minus 2 must be discarded. So that means only one element is consisted in this set, then that is 2. From the second condition, obviously we are getting 2 plus 2 and minus 2. But from the first condition is given must be x must be natural. So we have to consider only one element, that is 2, because 2 is natural, minus 2 is not. So we cannot include minus 2 here. So this set comprises only one element. Oh, obviously it is finite. Similarly, in the third example, twice x minus 1 is equal to 0, second condition. And this relation gives us x is equal to half. From the first condition, x is natural. So x must be natural. From the second condition, again, we are getting x is equal to half. But half is not natural. So that means satisfying both the conditions, we do not get any element. Do not get any value of x. From the second condition, no doubt you can have the value of x, which is half. But for the first condition, we cannot include this half. So this set has no element. This set has no element. It's empty set, null set, or void set. In the example 4, x belongs to n and x is prime. X belongs to n and x is prime. X is prime number and x is natural number. So all prime numbers, natural prime numbers, are the elements of this set. So obviously it is infinite set, because the set of prime number is quite infinite it is, and these are natural also, so it is infinite set. Similarly, in the next one, x is natural and x is odd. That means collection of all odd natural numbers are here in this set, and which is obviously infinite. Let's see when two sets are said to be equal. The equality of sets. When two sets are said to be equal. Two sets A and B we call equal if they have same elements. If they have same elements. Which elements are there in A? Exactly same elements must be there in B, and vice versa. Number of elements must be different, because in particular set a particular element might be repeated. So in that sense, number of elements might be different, but elements must be same in both the sets. And it is mathematically written just A equal to B. It is exactly like our general algebra. So in the following example, if you look at here, A is equal to 1, 2, 3, 4 and B is equal to 3, 1, 4, 2. Just order of the elements is different, so which is not bothered about this. So order is not mandatory to be maintained. So 1, 2, 3, 4 and here 3, 1, 4, 2. So after all, elements in both of the sets are exactly same. So in this sense, sets are equal. A is equal to B. So thus we say the equality of two sets under one condition, that the elements must be same. Here in exercise, few examples, and look at here, set of odd natural numbers divisible by 2. Set of odd natural numbers divisible by 2. Which of the following are examples of null set? Is it null set? Set of odd natural numbers divisible by 2. Odd numbers are not divisible by 2. So obviously it is empty set, a null set. Set of even prime numbers. Even prime numbers. Is it null set? No, obviously not, because there is one and only one even number which is prime, and that is 2. It is even. So set of even prime numbers means only one element is there, that is 2. So it is not one element is there. So it is not null set. X is a natural number, x less than 5, x greater than 7. In this set, if you see, x is natural number which is less than 5 and greater than 7. That means is there any number which is natural number which is less than 5 and greater than 7, which is not possible. So no element exists. So it is empty set, is null set. Similarly, y such that y is a point common to any two parallel lines. Y is a point common to any two parallel lines. So when two lines are parallel, no common point exists. So no common point will be there which is lying both the lines, which is not possible for parallel lines. No common point exists. So it is obviously null set. Example number 2, if you look at the finite and infinite, we have to say the set of months of a year, obviously finite. 1, 2, 3, dot dot dot, so on. This is called infinite set. 1, 2, 3, 4 up to 100. So this is obviously finite set. Set of positive integers greater than 100. How many numbers are there? Infinite numbers are there. Integers which are greater than 100. Infinite set. The set of prime numbers less than 99. The prime numbers less than 99. So few prime numbers will be there which are less than 99. So it's finite. So thus we can distinguish whether a set is finite or infinite. In the next example 3, if you look at the set of lines which are parallel to x-axis, obviously infinite set, because infinitely many lines you can consider, you can imagine, which are parallel to x-axis. The set of letters in the English alphabet, obviously finite. The set of numbers which are multiple of 5. Set of numbers which are multiple of 5. So infinite multiples of 5 are there. So clearly it's infinite set. The set of animals living on the earth is finite. The set of circles passing to the origin, so it is infinite, because to the origin infinitely many circles we can consider, we can construct. Let's look at equality. Example number 4. A is given here comprising 4 elements, A, B, C, D. B is another set which comprises D, C, B, A. It is number 1 example. These two sets, A and B. So here obviously A equal to B, because A and B comprise same elements. In example number 2, A is the set which comprises 4, 8, 12, 16. B is another set which consists of 8, 4, 16, 18. So here A is not equal to B, because elements are not same. 18 is present in B, but 18 is not present in A. So after all, elements are not same. So it is not equal. That means A is not equal to B. In the example number 3, A consists of 2, 4, 6, 8, 10. 4, 6, 8, 10. B is another set which is given, which is expressed in set builder form, x such that x is positive even integers and x is less than equal to 10. Positive integers, even integers less than equal to 10. So From the set B, if you say which elements are there in B in tabular form, if you observe what elements are there in B, then we look at X condition is given, X less than equal to 10, and X is even and positive. So obviously B will consist of 4, 6, 8, 10. 2, 4, 6, 8, 10, and these are the actual elements of the set B. So A is equal to B because they have same elements. It is just it is different in looking because B is expressed in set builder form, A is given in tabular form. So it is in look different, but they have same elements. A, number 4 example, A, X such that X is multiples of 10. X is a multiple of 10. That means A consists of all multiple of 10. Collection of all multiples of 10. And B said, which is what? Which consists of 10, 15, 20, 25, 30. Here all are not multiples of 10. Multiples of 10 are here in B also, but some numbers are there which are not multiples of 10, 15, 25 like this. These are not multiples of 10. But A consists of all elements are multiples of 10. So obviously they are elements, that means elements of A and elements of B are not same. Next, look at example number 5. Are the following pair of sets equal? Again on equality. A consists of 2 elements, 2 and 3. B consists of 2 elements here, and these 2 elements we can have just solving this quadratic equation. If you solve this quadratic equation, you will have 2 values of X. Solutions of X, you will have 2 values. And if 2 values are exactly same with this values, with these elements of A, then obviously equal. And if it is different, then the sets are not equal. Example number 2, X such that X is a letter of the word follow, F-O-L-L-O-W. B another set which consists of the letters of the word W-O-L-F. So A actually the set which consists of the letters F-O-L-W, and B is also a set which consists of same letters W-O-L-F. So letters which are contained in A exactly same contained in B. So elements of A and elements of B are there equal. So the sets A and B are equal. In the next and last example 6, from the sets given below select equal sets. So there 8 sets are given. 8 sets. From the 8 sets we have to pick up equal sets. Which pairs of sets are equal? If you see here A 2, 4, 8, 12. B 1, 2, 3, 4. 4, 8, 12, 14. Like this. So which A, no any other set is here which is equal to A. Which B contains 1, 2, 3, 4. Again D also 3, 1, 2, 4. So B we can say equal to D. So B and D are equal. Similarly, if you see C, which consists of 4, 8, 12, 14. And if you look at, no one set is here which consists of these elements 4, 8, 12, 14. So C is not equal with any one set. E, which consists of minus 1 and 1. Again, minus 1 and 1 are contained in set G. So obviously E and G are equal. E is equal to Z. And F contains 0 and A. And containing 0 and A, no set is here. So F is not equal with any other set. Last set H is H, which consists of 0 and 1. And this element 0 and 1, only 0 and 1 contain nowhere. So that means H is not equal with any other set of this group. So we have finally B is equal to D and E is equal to Z. Other than this, whatever pair you consider, all will be unequal. So that's all for you in this session, which was about finite, infinite, and equality of sets. Thank you so much.